Here is an example from a textbook. You can pause this video and try to solve the question by yourself. First question, identifying the relevant variable and parameter. The variable will be the number of hours worked by females in the previous week. The parameter will be population mean, number of hours worked by all females in the United States in the previous week. Then we need to calculate the test statistics in this way. Before that, we want to state the hypothesis. The hypothesis will be mu equals to 40. The alternative hypothesis will be mu doesn't equals to 40. So 40 will be mu 0. So the test statistic will be calculated as the sample mean minus the mu 0 divided by the ratio between sample standard deviation and the square root of sample size. Please verify this calculation by yourself. The sample mean of 37 hours falls 4.8 standard errors below the hypothesized value for the population mean 40. When we report and interpret the p-value for the test statistic value, we can use StatCrunch to get the p-value. Here is the StatCrunch output. The probability of observing a test statistic this extreme or even more extreme when the non-hypothesis is true is less than 0.01%. That's the correct interpretation we want to write down. So since the p-value is less than the level of significance 0.1, we reject the non-hypothesis. Remember that a small p-value means it is not likely that we could have gotten that test statistic negative 4.8 if in fact the true population mean was the value in the hypothesis 40. The correct interpretation will be with a p-value less than 0.001. There is sufficient evidence that the mean number of hours worked by females in the United States in the previous week is different than 40 hours. You can also use StatCrunch to compute the confidence interval for the same problem. Here is StatCrunch output. So we are 90% confident that the true population mean number of hours worked by the females in the United States in the previous week is between 35.97 and 38.03 hours. Notice that the confidence interval could have been used to tell us the following. This is evidence that the mean number of hours is different from 40, since 40 is not in the interval. Notice that the 40 is larger than the upper bound, so 40 is not in the interval. And we could tell that the mean number of hours is less than 40, because 40 is larger than the upper bound of a confidence interval. Here is another example from your textbook. You can pause this video and read the question. Step 1. Checking assumptions. The variable is quantitative because the variable is the number of cigarettes. The question tells us it is a random sample, so we don't need to worry about this problem. The question doesn't tell us about whether the population distribution is approximately normal distributed or not. So we can determine how much of an issue this is by looking at the sample size. Since the sample size is larger than 30, we are not as concerned about not knowing the population distribution. Ideally, we would like to be able to look at the histogram of the data to identify whether there are any outliers or major skewness. Step 2. State the hypothesis. The hypothesis will be mu equals to 18.1 and the null hypothesis will be mu less than 18.1. It is less because this is how the question asked us. See, the number of cigarettes smoked per day by daily smoker is less than this number. Step 3. Calculate test statistic. And the test statistic will be calculated in this way. The simple mean is given. Mu 0 is given in the null hypothesis. The sample standard deviation is also given. And we can find the sample size from this line. Step 4. Calculate p-value. In this example, we will use StatCrunch to calculate the p-value. And here is the StatCrunch output. The probability of observing a test statistic this extreme or less when the null hypothesis is true is 4.4%. Step 5. Make conclusion. Since p-value is larger than alpha, we do not reject the null hypothesis. The correct interpretation will be with a p-value of 0.044. There is insufficient evidence that the mean number of cigarettes smoked per day by daily smoker is less than 18.1. And we can calculate confidence interval for the same problem. Here is StatCrunch output for the confidence interval. We are 99% confident that the true population mean number of cigarettes smoked per day by daily smokers is between 14.79 and 14.81. Notice that the confidence interval could have been used to tell us the following. There is evidence that the mean number of cigarettes could be 18.1 because 18.1 is in the interval.